Hi, welcome back to McClutchy Maths. My name is Natalie McClutchy, and today we are looking at video 7 in our index laws series, and our focus today is on negative powers. Now, so far we've been dealing mainly with positive powers. We've had a couple of answers in some of our previous videos where the answer was a negative number, but today we're looking at how do we present anything that ends up as a negative number as a positive power. You might be thinking to yourself, does that even make sense? It will when you watch the video. The first thing we're going to do is we're going to derive our rules. So we're going to do what we've been doing in our previous videos and show you why this law exists, and then we're going to do some examples. Okay, so far, let's just build up our positive index laws first. So we've seen that 10 to the power of 1 is equal to 10. Anything to the power of 1 is just itself. Now, if I square the number 10, I get 10 times 10, and that's equal to 100. And you can start to see a little bit of a pattern emerge. Every time I add an extra power on, a power of 3, for example, I'm going to be building up that number 10. It's now 100, then 1,000. I'm guessing you know where it goes next. It goes to 10,000, and so on. So as we add a power of 1 on, 10 to the power of 1, to the power of 2, to 3, to 4. What we're finding is that numbers multiply by itself an extra time, and that gives us a new placeholder. So we could infer, for example, that 10 to the power of 5 would be equal to 100,000. But let's now have a look at what happens when we go backwards. These are all positive powers, but this video is about negative powers. So we want to look now at what happens with our negative powers. So if we get 10 to the power of 0, and we saw this in our zero index laws video, that's equal to 1. So this also is a nice little way of showing you why it is equal to 1. You can see going backwards, we've now dropped that 0. What happens now if we go one number back? That's going to be negative 1. So first of all, what I'm going to do is show you what's going to happen by adding a decimal place to each of those numbers. So in each of these cases, you can see if we start, for example, from the bottom, that as we go along, we're moving that decimal point to the left by 1 placeholder. So if you could have a guess about what's going to happen next, 10 to the power of minus 1, we're going to move that decimal place 1 step backwards, and we get 0.1. If we do that again, 10 to the power of negative 2, 0.001. So 0, 0, yeah. So as we go through this, the higher the power is, the bigger the number gets. So to go from, for example, 1 to 10, it's multiplying itself by 10. We multiply by 10 again and keep multiplying by 10. We're going to end up with some very big numbers as we get out in towards infinity. If we go backwards, we're dividing by 10 each time. So if we take 1 and divide by 10, we get 0.1, divide by 10 again, we get 0.001, and if we go backwards again, we're going to get 0.001, and so on, all the way back to as many negative numbers as you can think of. Now, let's express this. So we can see a nice pretty pattern occurring with our decimal numbers, but let's express these as fractions, and this might start to make even more sense for you in a moment. So, all decimal numbers are also able to be written as fractions. If we think about what this number here is, it's actually 1/10th. This is 1/100th, 1/1000th, 1/10,000th. So that's all our different place values there. So we're going to pop those numbers in, and you can see when I've popped those in what that looks like. So if you remember, when we had 10 to the power of 1, the answer was just 10. 10 squared was 100. Well, now we've got 1/100th in the opposite direction. So now let's express these numbers at the bottom as powers, like we started with when we first developed our pattern. So now you can see we've got 10 to the power of 1 on the denominator, 10 to the power of 2 on the denominator, 3 and 4. So as you can see, we've got this really neat pattern happening there when we move to negative powers as well. In fact, we've now got a new rule that we can develop, because all of these negative powers can actually be expressed as fractions with a positive power. And sometimes the question will be quite happy for you to leave your answer with a negative power, but sometimes you'll be asked to express your final answer with a positive power, in which case you're going to need to be able to convert all of these negative powers to fractions. You'll notice here a little bit of something. The 4 here and the 4 here are the same. The 3 and the 3 are the same. The 2 and the 2 are the same. 1 and the 1, and so on. The 10 also stays at the bottom here. So basically, you could create a rule for yourself that to express this number here as a positive power, you simply turn it into a fraction with 1 as the numerator everything here goes to the bottom and the power changes from negative to positive. So that's one of the rules that we're going to come up with now. And here we have it in algebraic form. So you would remember from our previous slide, and we'll just jump back there in a second. From our previous slide, we just talked about how we can turn this to the denominator, the numerator becomes 1, the power goes from negative to positive, and this is exactly what's happening here. So we've got A could be any number or any letter. If it's got a negative power, we simply turn it into a fraction with 1 as the numerator. This comes down to the denominator and the negative turns to a positive. And we've seen why that works using powers of 10 or bases of 10. So this is our rule. You just need to remember it and remember how it works. It also works in reverse. So if I start out with a fraction and the fraction has a negative power in the denominator, I can simply change that back, get rid of the fraction altogether, turn it back into a whole number, and the power becomes positive. So let's see how this works with a couple of examples. So we're asked to express 3 to the power of minus 2 with a positive power. So here's my rule. This is what you need to memorize. And I'm going to match the question underneath. So I've now got, instead of an A, I've got a 3. Instead of an M, I've got a 2. So I'm going to express that as 1 over 3 squared. And I could actually evaluate that as well. The question doesn't tell me to evaluate the answer, but it's always good practice to simplify things further. 3 squared is a 9, not 6. Don't make that little mistake there. 3 times 3, not 3 times 2. Let's look at another worked example. We're asked now to use that second version of the rule. We've got this number on the denominator. It's got a negative power. We need to re-express that with a positive power. So let's pop our rule there that we need to memorize. So you can see here, if I match things up, this A is represented by the 5, the M is represented by the 3. So what's going to happen is the fraction is going to go away. It's going to turn into a whole number. The 5 is going to come up here, the 3 is going to come up here, and the negatives are going to go away. So now we've got just 5 to the power of 3. We could simplify that further as well, because 5 to the power of 3 means 5 times 5 times 5, which is 125. Let's look at another one now with some algebra in it. So for some people that gets a little bit confusing. All it is, you've just got to memorize that rule. So I've got this y to the power of negative 8. I've got to express that with a positive power. So what's going to happen here is this y is going to replace the a. So y is going to become part of a fraction. Y will go on the bottom. 8 will go on the denominator as well. No more negative powers. So it simply is 1 over y to the power of 8. And let's do another worked example now with this one here. This one's a little bit more complicated. What I've tried to do here is combine a few laws together. Our answer is going to end up with a negative power, and then we're going to have to simplify that at the end. So firstly, I can see I've got two different bases, an A and B. So let's evaluate the A's first. Remember, when they've got this divided by, that means it's our takeaway rule. So I've got the same bases of A. 7 will be taken away from 10, so 7 take away 10. And then I've got B, so that's my second base, 12 take away 5, because this divided by rule means that I'm going to subtract my powers. Okay, so let's simplify that a bit further. 7 take away 10 is negative 3. Now this is where you've got to be really careful, because a lot of people forget that they're dealing with negative numbers and they accidentally switch things around in their head and do 10 take away 7 by accident. So use your calculator if you're not sure. 7 take away 10 is negative 3, 12 take away 5 is positive 7. Now we've got this far, but the question also says express with a positive power. A lot of people will leave it here because they aren't sure what to do next because they haven't memorized the rule. You've got to get it into your head. So have a look at the question. A has a negative power, B does not. So B is not going to change at all because B's already got a positive power. We don't need to do anything with B. We do need to turn this part here into a fraction. So if you remember our rule from before, this will become a fraction with 1 as our numerator, A to the power of 3, because the negative will turn to a positive, will go onto the denominator. You might be wondering what happens to the B to the power of 7. Well, B to the power of 7 will go on the top. Now, here is why. We've got this fraction, 1 over a to the power of 3. That's the a part. And it's multiplied. There's an invisible times sign right there. Multiplied by b7. So I could have this part of the fraction times by b to the power of 7. That wouldn't be wrong, but it wouldn't be fully simplified. Now, our rule is when we're timesing a fraction by a whole number, any whole number can be expressed over 1. And so that b to the power of 7 is also a fraction over 1. And our rule when we times fractions, and we've done this in some of our previous videos, is we times across the tops, times across the bottoms. So b7 times by the 1 becomes just b to the power of 7. And this a to the power of negative 3 pops onto the bottom there. Well, did you find this video helpful? I sure hope so. If you did, here's some ways that you can engage further with the channel. First of all, you could like and subscribe and hit that notifications bell so you'll always know when the next video is coming up. You could also follow us on social media. We're on Facebook and Instagram. Just look for McClutchy Maths there. You could also tell us in the comments. I love to hear your feedback. It's really helpful. And also just, it's like my little treat, my little reward. Love the positive praise. Can't get enough of it. So please tell me in the comments if you liked the video today, or just give us a thumbs up. Well, thank you so much for watching. And if you've got any questions at all, the best place to reach me is at mcclutchymaths@yahoo.com. And you've been watching McClutchy Maths. I'm Natalie McClutchy. We've reached the end. Have a wonderful day.